This next section is 3-2 and it's on factoring trinomials. Trinomials look like this. They have a variable in the front with a power of 2. They have some number. I'm going to put it in a different color. We'll call that number b. And that number also has a variable, the same variable, hooked onto it. And then you have some number in the back called a constant, and we'll call it c. So there's actual numbers where these red marks are. So let me show you one with numbers in it. It's a lot easier. I just wanted to show you the format of it. So an example of one would be x squared plus 5x plus 6. This is a trinomial. So a trinomial will have 3 terms in it. The trinomials that you're dealing with right now will always have a power of 2, and then a power of 1, and then a constant. In the previous lessons, you took binomials. Let's call this x plus 2 and x plus 3. And you simplified them out. Simplifying meaning getting rid of the parentheses. And so the book called it foiling. We talked a little bit about it. You multiply the 2 first terms, which gives you x squared. And the outer terms, the O for the FOIL, so x times 3 is 3x. Then the inner terms, 2 times x is 2x. And the outer terms, 2 times 3 is 6. And then you learn that those 2 inside terms, when you do that, end up being like terms, and so you can combine them. 3x plus 2x makes 5x plus 6. Okay? And this was the answer, the simplified answer. So when we multiplied binomials, we ended up with a trinomial. Well now, so before we were going from here to here, but in this chapter, in this section, it's all about going from, from here to here. So it's going backwards. So just like last section we undid the distributive property, this time we're undoing the multiplication of binomials. So we're like reversing the simplification. Okay, so let's take a look at this. If I take a look at that problem again, x plus 2, or x plus 2 times x plus 3. And I multiply it again. So I get x squared plus 3x plus 2x plus 6. This middle part ends up adding to 5x. The front part is x squared. And this back part is 6. And can you see where I could get a 6 originally? So let's look at the original numbers in the problem. First terms are x's, so they're going to be x squared, so that's not bad. And remember, we're trying to figure out how you go from here to here. Okay, so how could I get 5x from this 2 and this 3? Well, don't 2 plus 3 add up to 5? So I know I'm looking for something that adds to 5. And then if I look at the 6 part of it, isn't 2 times 3 6? So I would have been looking for something that multiplies to 6. So let's say all of this isn't there for you. All you see is x squared plus 5x plus 6. That's all you get, and you have to figure out how it goes in these parentheses. Well, you know that the first 2 terms are going to be x. You know that this middle term, the 2 numbers added to that, so you know it has to add to that. And you also know that it multiplied to this last term of 6. I'm going to put a 1 right here. So what the pattern is that you're looking for numbers that multiply to the combination of these two, so that they're the product of the first leading coefficient and the last constant. and then you're looking for something that adds to the middle term. Okay, this looks confusing at first. Once you get the hang of it, you'll be okay. So let's do another one. So what about if I had x squared plus 6x plus 8? So again, I'm looking for something that multiplies to the combination of these two. And right now, we're just dealing with the leading coefficient of 1, and that's all we do in 76D. When you get to E and F, that leading coefficient will be a different number. It will be a number bigger than 1, and then they'll show you how you can use your regrouping to figure out what that first number in the factors are. Okay, but for now it will always be this last number, but I don't want you just thinking it's always the last number. It's actually 1 times that last number. So we're looking for something that multiplies to 8 and then it adds to the middle number. So it adds to 6. We know that it's going to look like this, so I might as well do that. Okay, so the things that multiply to 8, the reason why I put multiply first is if I sit there and talk about what adds to 6, I could go, 6 plus 0, 5 plus 1, 3 plus 3, and there's a lot more things that add to 6 than there are that multiply to 8. And if we have to meet both of these criterion, we should start with the multiply. So the things that multiply to 8 are 1 and 8, and 2 and 4. And you should know that if it's an even number, 2 goes into it. Okay, so those are the things that make 8. So if we talk about adding these two add to 9, so they don't meet the criteria. But these two add to 6. So I know the two numbers are 2 and 4. Done. Now if you don't know, if you're like, oh gosh, I'm on a test, I don't know if that's right, I have extra time at the end of the testing time, then FOIL it. X times x is x squared. X times 4 is 4x. It's a good idea to make yourself FOIL a few of them, even on homework, because you will get better at FOILing. And remember, if you've been watching these videos, when we started FOILing, I said it's probably one of the most important things in the first year of algebra, because it has a lot to do with the quadratic equation and parabolas. And so you spend a lot of time in algebra, in the later part of algebra, the first year of algebra, on that. So x squared to finish this off. And then I know that I'm right because this is right back where I started. But that's not the answer they're looking for. Remember, they're looking for you to unsimplify it, if that's a word. So they're looking for those binomials. Okay? I can't stress enough on this factoring, how important it is. And even if you do this assignment, you do the next two assignments, I would definitely make myself do 2 or 3 of these every night. Okay? Try this one. X squared plus 7x plus 12. So try to think back to the last example. What am I looking for? I'm looking for two numbers, and what am I wanting them to multiply and add to? I'm wanting them to multiply to 1 times 12, which is 12, and I'm wanting them to add to positive 7. So if they multiply to a positive and add to a positive, they must both be positive, because a positive times a positive makes a positive. And so 12, 1 and 12, 2 and 6, 3 and 4. And if you get stuck, I get students that don't want to write stuff out, and then they go, well, I couldn't find anything that it factored to. I couldn't find anything that it multiplied to. Force yourself to write if you get stuck. Just start writing them out in order. Does 1 go into it? Does 2 go into it? Does 3 go into it? Does 4 go into it? Okay? So these make 13, so no. These two make 8, so no. But these two make 7, so bingo. We found our match. So it's x plus 3. It's plus 3 because it was a positive 3. And x plus 4 because it's positive 4. Try this next one on your own. Maybe pause the video See if you can do it on your own. Okay. So I'm looking for something that multiplies to 30 and adds to 13. So 30 and 1. I know that's kind of silly that I always put the 30 and 1 or the 12 and 1 first, but sometimes those are the ones people forget, the more simple ones. I'm just in the habit of doing it. If it ends in a 0, I know 5 and 10 both go into it, so I can go 5 times 6 and 10 times 3. Okay, so let's start looking at the addition. 30 and 1 do not add to 13. 5 and 6 do not add to 13. 10 and 3 do add to 13, so bingo. X plus 10, x plus 3. I could also put x plus 3 and x plus 10. That's again that commutative property. I'm going to multiply them. They're being multiplied together, so it doesn't matter which one goes first. Okay, so either answer is correct. A good place to go to practice more of these, I mean, you can go to your book too, because your book has more examples. Imagine, I haven't looked in the very back of the book, I'd imagine there's even more practice problems in the back of the book. But if you go to AAAmath.com, they go from, I don't know, first or second grade all the way up to college with different problems for different concepts. So you'll find a place where you just type in factoring trinomials, and then it will just give you a bunch of practice problems. It actually gives you a choice of lesson, practice, or quiz. And I always tell my students, go to the practice because it's kind of nice. It gives you a problem, then you do it, and then it tells you right away if you're right or wrong. It gives you another problem. So I would strongly suggest doing, even though we finish this section, doing 2 a day for the next 4 weeks if you're going on to the next math class. It'll pay off. Next problem is x squared plus 9x plus 20. So you're looking for something that multiplies to 20 and adds to 9. So 20 and 1, nope. Okay, 4 and 5, yep. So x plus 4, x plus 5. Done. Again, you can FOIL it back to make sure. What about if these aren't positive? What about if it looks like this? X squared minus 7x plus 10. So that makes it a little different. Makes it a little more difficult. You can handle it. It still multiplies to 10, but it adds to negative 7. You got to watch those signs. So if you're going to talk about two numbers that multiply to a positive but add to a negative, if you think about back when you learned integers, you know that a negative times a negative makes a positive, and a negative times a positive makes a negative. So if they're different signs, they're negative. If they're same signs, of course a positive times a positive makes positive. If they're same signs, they're positive. So if this is going to multiply to a positive, it's one of these. And now if it's going to add to a negative, it can't be that, because two positives can't ever add to a negative. So that means both of your numbers have to be negative. So negative 10, negative 1, whoops, those add to negative 11, so that didn't work. 2 and 5, negative 2 and negative 5. Those two add to negative 7, so bingo. So when we place them into the binomials, it's x minus 2, x minus 5. When you are looking at when the signs aren't positive, it always makes it a little bit higher risk that you're going to find an error. Again, if you have time at the end of a test, and I know that your final is timed, so I would go through and do the problems, and then if you know you have extra time, put stars by the ones you want to go back and recheck. And then definitely it's worth it to spend the time rechecking. So x times x is x squared. X times negative 5 is negative 5x. negative 2x, positive 10. So watch your signs. These two add to a negative 7x. And then you look to see, does this one look exactly like the original? Yeah, so then you know you're right. But remember, this is the answer. Okay, so try this next one. Oh. X squared minus 8x plus 15. So again, you're looking for something that multiplies to 15, adds to negative 8. So 1 and 15, and you know they both have to be negative. That didn't work. 3 and 5 are the only other factors. So you double check them. If they were both negative, they would add to negative 8. So x minus 3, x minus 5. Okay, and one more practice problem here. So you're looking for something that multiplies to 18 and adds to negative 9. You know that they both have to be negative, because a negative times a negative equals a positive. And if you add negatives, they just equal bigger negatives. So you know it has to be two negatives. So negative 18 and negative 1, nope. Negative 9 and negative 2, nope. Negative 6 and negative 3, 6, 7, 8, 9, yep, that works. So y minus 6, y minus 3. Okay, so what about if not just this is negative, but what about if both of them are negative? Let's do some of those ones. So you have x squared minus 3x minus 4. So let's think about this. It has to multiply to a negative 4 and add to a negative 3. Well, if it multiplies to negative 4, that means one of them has to be a positive and one a negative, because that's the only way you get a negative. And think about this, if you think back to your integers, I don't know how good you were at adding integers, but if it adds to a negative, that means the difference between the two numbers has to be 3. And that the bigger, not bigger number, but bigger absolute value has to have a negative on it. So that's kind of confusing. I'll explain as we go. So if you look at 4, so it either, you could have this, or you could have this, or you could have this, or you could have this. And these two are going to be the same thing. So let's look at what they add to. So negative 4 plus 1 makes negative 3. And we just happen to get the answer right away on that one. So what I was saying is they have to be 3 apart. If you if you ignore this negative part, 4 take away 3 is 3. And then you know that the negative goes on the 4. Because if you have 4 negatives, if you have 4 negatives and you add one positive to it, a negative and a positive will cancel each other out, and you'll have 3 negatives left over. And so you have x minus 4, x plus 1. Sorry about that long explanation if you didn't need that. Okay, and then you always double check it. So when these two are negative, you'll always get a negative and a positive. So try this one. X squared plus 7x minus 8. So you're looking for something that multiplies to negative 8 and it adds to 7. So if it multiplies to a negative, one's negative, one's positive. So if you look at 8 and 1, the difference between them is 7. So that means this must be it, and the negative must be on the 1. because the 8, you want the leftovers to be positives. If you're not good at your integers and that confuses you, please make sure you use your calculator to just double check them. Okay, so x plus 7, x minus 1. It's so easy to get these the negative on the wrong number, and then everything goes bad. So really important. One more. You might want to pause it and try this one on your own. So it has to multiply to negative 24 and add to negative 2. So that means the numbers have to be 2 apart. So like 24 and 1, if one of those is negative, that's never going to work because they're 23 apart. The difference has to be negative 2 between them. So like 6 and 4 have a difference of 2. So those both, if I put a negative on one of those, they'll multiply to negative 24. I'm going to put a negative on the bigger one because I know I want them to add to negative 2. So t minus 6, t plus 4. And again, FOIL it back to make sure. Okay. Sometimes you get problems like this. And you're sitting there going, it's got to multiply to 12 and add to 9. And you go, okay, 1 and 12. No, that doesn't do it. 6 and 2. No, that adds to 8. That doesn't do it. 3 and 4. That adds to 7. That doesn't do it. And then you're out of options. There's no other options that multiply. There's no other factors that multiply to 12. So this is called prime. So how you write your answer is you just rewrite the actual problem. Let me relate it to numbers. Like if I took 12 and I asked you to factor it, you could say 3 times 4. Okay, or you could say 1 times 12 or 6 times 2. But if I took 11 and I asked you, what are the factors of 11? You'd say only 1 in itself, 1 and 11. So that means the factors of x squared plus 9x plus 12 are only x squared plus 9x plus 12 times 1. And so your answer is just repeating the problem. Don't assume there's a ton of primes on assignments. Don't go, oh, I can't do this one, so it must be prime. Make sure you exhaust all the possibilities of factors before you say it's prime. There's a table on page 810. It's orange. It kind of summarizes it. Might be really good for you to look at. You don't want to use that table every time you go to do one of those problems, because then you're trying to memorize, oh, one's got to be negative, one's positive, if the negative's here, and if the positive is over here, this is what happens, and you will not retain that very long. So it kind of summarizes it to maybe so you can wrap your brain around it, but don't depend on it. But it is a nice summary. Okay, and then a little bit harder problems. If you have a problem like this, and you start saying, oh, crud, are you kidding me? What multiplies to 7 times 42 and then adds to 35? Those numbers are so big. Think about the last section, what I kept saying. Look at your greatest common factor. Look at your greatest common factor. When I teach this in a regular classroom, for days I say, what's the first thing you look for? And I make them repeat, greatest common factor, until it's totally in their head. So if I look at these numbers, if I look at these terms, the numbers have a 7 in common. They don't have an x in common because the 42 doesn't have an x. But they do have a 7. So I can simplify these numbers by factoring a 7 out. And we did that in the last section. Okay, once you factor those numbers out, then it's easier to factor this part. So now I can say, okay, what multiplies to 6 and add to 5? Add to 5. Well, that's 3 and 2. So I can go x plus 3, x plus 2, and I also have that 7 out there. That right there is easy to forget to bring down. I probably should have brought it down. But so this one is a little bit more difficult because it doesn't just factor to 2 binomials. It factors to 2 binomials plus another number. Okay, so for right now, if you see this number out here, you know you have to find a factor out of GCF. When you get to your next algebra course in the line, you'll find out that that's not a guarantee every time there's another number out front that you're going to be able to factor something out. But that you'll cross that bridge later. Okay, so try this one. 2x to the fourth minus 4x cubed minus 6x squared. So a GCF would be 2x squared. So this time we're bringing a variable out with our GCF because they all had x's. This one had 4, this one had 3, and this one has 2. So the only common is 2. So if I divide, remember last section when we talked about when you factor it out, it's dividing by it. So if I imagine dividing that by 2x squared, I get x squared. If I divide this by 2x squared, I get minus 2x. If I divide this by 2x squared, I get minus 3. Now I can try to see, once I have a trinomial and I notice that this squared is there, that is a strong indicator that you can factor it. So what times what makes negative 3 but adds to negative 2? Okay, so if it's multiplying to a negative, that means one of them is negative and one of them is positive. So negative 3 and positive 1 adds to negative 2. So there's your magic numbers. X minus 3, x plus 2, and don't forget to bring that guy down. So there's your final answer. Whoops, there we go. Okay, one more application. Make an application to algebra. As you get farther into algebra and into geometry, you find out that factoring has a lot to do with areas. To find the area of a rectangle, it's length times width. So if all you knew was the area, and you knew the area was x squared plus 6x plus 5, and you wanted to find out what the dimensions were, then you want to know what times what makes this. Okay, so you factor it. What multiplies to 6 and adds to 5? That's 3 and 2. And the more you do these, the faster you get because you see the same thing over and over. Okay, so I know that when you're first factoring, you're going to hate this assignment at first. You're going to go, oh my gosh, it takes me so stinking long, especially if you're not good at adding and subtracting negatives and your multiplication. But stick with it. I swear, after you do a bunch of them, all of a sudden the light bulb goes on and they become super easy. Okay, so I know that this must be x plus one of these. I'm just going to put x plus 3. This must be x plus 2. So there's your application to it. Okay, don't give up on this section. I know that this can be a very frustrating section for people, but I tell you, this is probably the most important concept that keeps reoccurring down the line in algebra. So good luck with this. Let me know if you have problems.